Just know, and I'm gonna miss you. I know. But when I'm if you love someone, you should let them know. On the night that you left me, will ever go. I feel so unsure as I take your hand and lead you to the dance floor. As the music dies, something in your eyes calls to mind the silver screen. It's sad goodbye. I'm never gonna dance again. Guilty feet have got no rhythm. Oh, it's easy to pretend. I know you're not a fool. I should've known better than to cheat a friend and waste the chance that I could have given. So I'm never gonna dance again the way I danced with you. Time can never mend the careless whispers of a good friend to the heart and mind. Ignorance is kind, but there's no comfort in the truth. Pain is the whole you'll find. I'm never gonna dance again. Guilty feet have got no rhythm. Though it's easy to pretend, I know you're not a fool. I should've known better than to cheat a friend and waste the chance that I did. So I'm never gonna dance again the way I danced with you. Never without your love. Tonight the music seems so loud. I wish that we could lose this crowd. Maybe it's better this way. We heard each other with the things we wanted to say. We could have been so good.
Hello, everyone. Good evening. How are you? Welcome back. Good to see you.
Good evening, Professor.
How are you, Miss Christina?
I'm
Good
good,
weekend?
thank you. I'm good.
Good evening.
Yeah. That was
Hello,
Mother's Day.
everybody.
That was Mother's Day. Not everybody celebrates it, I guess. No
That's
presents.
I was able to celebrate it with
Okay.
with family and friends.
Okay, that's
It was
good.
good, thank you.
All right. Okay, so last time we met, we're waiting for just one more person. Anna, but that's okay. We'll start. Last week we met. I gave you homework, right?
Yes.
I just a little review of what was being done in class. So let's start off with that. Here it is. Just ignore the names that are on there. But here it is. So who's got number one?
I think I do.
Okay, what's the answer?
That would be 2.8 kilos.
2.8 kilograms.
2.8, yeah.
Kilograms. Does anyone have a different answer than that? No? Do we all agree? 2.8 kilograms, very good. And which method did you use to solve this?
Well, I use the one that you taught us about the moving.
The 333? Okay.
Yes.
Good. So 2.8 kilograms. Oops. Now remember, you can also use proportions. Okay, so another way to say is, for example, 1 kilogram
Equal 1,000
1,000.
milligrams.
Correct. It's 1,000
What
grams.
about
No, it's
grams?
1,000 grams. So if you have 28 grams, how many kilograms is that? You can also use it solving this. Okay, so proportions is one way, and then the 333 system is also fine. Great. What about number 2, Ina? What did you get for that one?
So for 3 grams is equal 3,000 milligrams. So we have to convert.
Correct.
So 3,000 milligram over 250 milligram equal 12 tablets.
200 milligrams equals 12 tablets. Good.
Yeah.
Perfect.
I
That's
make some notes.
Yep. Excellent. About A, Ria, 3A.
Okay, so 1.5 gram, I think the patient should take 3 tablets of 500 milligrams.
Okay. And how did you solve this?
So 1 gram has 1,000 milligrams. So here 2 tablets and the other half.
Okay, so 1.5 is 1,500 milligrams, right?
Right.
Great. And then they want to know if they take this divided into 3 equal doses, which one should they take? And what 1,500 divided by 500 is equal to
3.
3, yes. What should have been the other way around, rather. Divided by 3 should have been 500 milligrams. Great. What about 3B, Christina? What if we increase that to 2 grams per day, divided into 4 equal doses? What should the dosage be?
Oh, it should be I don't know.
Okay.
Okay.
Is Anna in?
Because I forgot about this assignment.
What do we do here in this one, Miss Mia?
This one I wasn't really too confident about, but I put 500 milligrams.
Good. 500 is correct. Tell me what you did.
So I just did like the basic conversion method that like what we've been doing.
So 2 grams is how many milligrams?
200.
2,000 milligrams. Good.
Yeah.
2,000 milligrams. And if we divide that into 4 equal doses, that's going to give us the 500 here.
Yes.
All right, Anna, do you have number 4?
Yeah,
What's your answer?
that's 692.322 grams.
Through grams. Tell me what you did.
Well, first, convert everything into grams.
Okay, except for the first one, because
So,
this one's already grams. How
yeah,
much is this
and
in grams?
So then, yeah. So then 2,300 milligrams could be 2.3 grams.
2.3. What about 4.45 is 450?
Yeah, that's
Grams.
450 grams. 0.45 kilos could be 450 grams. And then 22,000 micrograms could be 0.022 grams. And then,
Okay.
add up all together, it could be 692.322 grams.
Great. Anybody get a different answer on this? Okay. So this is just simple conversions. Okay, we're going to be using this a lot in the other math portions. Great. So now let's continue. I don't think I showed you temperature conversions, right? I wasn't able to show you that
No.
last class. Great. I'm back in New York, by the way. So temperature conversions. Oops, let me make this bigger. And studies show that people tend to retain better the material when they're shown in Comic Sans font. Temperature conversions. So typically in the United States, we use one system of measurement, which is the Fahrenheit system. But pretty much everywhere else in the world, they use centigrades, or here we call it Celsius. So temperature conversion there's different formulas out there. I like to show just one here. And if you have your own and you want to keep using your own, stick to that one. That's fine. Just as long as you don't get the numbers mixed up, because there's some out there that require conversions or fractions. So I just want to make sure that you understand at least one of them, and that specific formula works going both ways. Okay, so and the reason temperature conversion is important is that if you recall, some of the labels on the medications show for example, the storage requirements. When medications come into the pharmacy, sometimes they come in a cooler, and you need to make sure that they go back into, or you place them or put them on the shelf in coolers as well. So that's important. Not in coolers, but in the refrigerator. Another thing is that we're making compounds. Certain products are stable at certain temperatures. So for that reason, we need to ensure that the temperatures that we know and use are understood. So here's an example of the types of temperatures that we use. So we use Celsius or centigrades, which is a unit of measurement that is used pretty much everywhere else in the world. So this is the international unit of measurement for temperature. Anybody know the freezing point
0.
of water? In the Celsius system, correct. The freezing point is 0 degrees. And that is represented by a capital C and the little circle symbol, which I'll have to type in a minute. And then the boiling point.
100.
Boiling point is 100 degrees. And then that's Celsius as well. Good. Then we have the Fahrenheit system. Which is an American unit of measurement for temperatures. American unit of measurement for temperatures. Their freezing point, anybody know? 32 degrees Fahrenheit, the freezing point of water in the Fahrenheit system. The boiling point is, I'm sorry, the boiling point happens to also be my birthday. It's 212 degrees, yes. So hint, hint. That's my birthday. I don't think we'll be seeing each other by then, but I like coffee. All right. So these are pretty much the 2 units of conversion. I should have put the circle in the other end. Okay. Now the formula that we use, or the one I like to use, is the following. And this one works for both conversions of Celsius to Fahrenheit and Fahrenheit to Celsius. Again, there's others out there. You're welcome to use them if you think they work well for you. But 9C is equal to 5F minus 160. That's the formula. Okay. So let's look at an example down here. We want to convert 80 degrees Fahrenheit to Celsius. So looking at this formula, first thing I always do is write down the formula. 9C is equal to 5F minus 160. The values I already know are the value of F, which is 80. So we're looking for C, so that's going to stay the same. 9C is equal to 5 times 80 minus 160. 5 times 80 is 400. Minus 160. All I'm doing here is bringing down the 9C. 464 minus 160 is how much?
240.
240. Good. 240. Bring down the 9C. Now I have to isolate my C, so I need to divide both sides by 9. That cancels out the 9. Then I have C by itself, and 240 divided by 9 is how much?
3.
26.7, about 26.7, 26.6666, right? Yeah. So this is going from Fahrenheit to Celsius. Now, what if we want to convert from Celsius to Fahrenheit? Convert 60 degrees Celsius to Fahrenheit, okay? Going the other direction, but using still the same formula. 9C is equal to 5F minus 160. Okay, degrees. So I know in this case, the value of C. So 9 times 60 is equal to 5F minus 160. 9 times 6 is 54. 5F minus 160. I get to bring the 160 to the other side. So I do the inverse operation. I need to leave numbers on one side and variables on the other. This cancels out. This becomes 700. And all I do is bring down the 5C, divide both sides by 5. This cancels out. And then I have F by itself. 700 divided by 5 is 140. 140 degrees. Okay. So this is pretty much using the same formula above that I showed you up here to solve from Fahrenheit to Celsius and Celsius to Fahrenheit. either direction. Questions on this? Okay, let me switch. I'm gonna switch to the other writing board. So let's convert 59 degrees Fahrenheit to Celsius. We'll have Anna convert 99 degrees Fahrenheit to Celsius. We'll have Mia then we will have 130 convert to Celsius. We will have Christina. We'll have 4 degrees Celsius. To Fahrenheit. Ria. Ina, and then the normal. (96.8 degrees to 100 degrees Fahrenheit. What is the range in Celsius? Pamela. Okay. Whenever you have your answer, just let me know. Work on the other ones also that were not assigned to you as well.
So mine is 15.
Yours is 50. Ina? Ina says hers is 50. This one?
No,
Oh,
mine,
Anna,
Anna,
sorry.
15.
15, yeah, okay. Everyone have the same answer? 15?
For mine, I got 37.2 degrees Celsius.
37.2 degrees Celsius. Okay. about the rest?
Mine is 39.
39. This is Ina. Ina?
Rhea.
Rhea, 39. Okay. How about Christina, Ina, Pamela? Pamela, I sent you a message in the chat.
Okay, let me check. Good.
Yep.
Ina, 101.1.
101.1. How about Christina? If you're stuck, let me know.
Yeah, mine
Chris-
is 54.4 degrees.
54.4 degrees, okay.
Yes.
And Pamela, what do you have?
Still working on it, please.
Okay. Ina, were you able to access the NHA?
Yeah, I think I did. Yeah,
Okay.
thank you.
I'm gonna
1 second.
start the next page, and then we're gonna go into dosage calculations. And then whenever you have your answer, let me know, okay, Pamela?
Yes.
Okay, now the next topics we're gonna cover are the following. Gonna be dosage, dosage calculations. We're also gonna cover concentrations and dilutions. We're also gonna cover allegations. I'm also going to cover parenteral calculations. And eventually, I'm going to end with business calculations for pharmacy. That's pretty much the topics in math. So let's continue with dosage calculations.
Before we
Yeah.
move on, I'm not sure if I got it right, and
Right.
I only have like an average because I don't know how to, I don't know if I had to do like 2 because
Decimal
of the
places.
100. So
Uh-huh.
I got 36 degrees Celsius, like to something else. So I don't know if it would be like 30. What was it?
36 and what? Give me the exact number.
I got 36.1.
36.1, and the other one is?
That I didn't get. Like, do I have to do like 2?
You have to do both. Yes, so you have to do both. So
Oh,
9
okay.
C is equal to 5F minus 160. So
Mhm.
we have 9C is what we're trying to find out. 5 times 100, oops, times 100 minus 160. So 9C is equal to 500 minus 160. This is a little off. So 500 minus 160 is how much? 340.
340.
9C, divide both sides by 9.
Mhm.
And then C is equal to 340 divided by 9. How much is that?
340 divided by 9. Wait.
43.3, about.
37.77.
How much?
37.77.
37.77. So 37.8. So we'll leave it at that.
Mhm.
Okay, great.
Okay.
That's pretty much it.
Okay.
All right. So let's continue now with dosage calculations. So dosage calculations are a set of calculations that are done for various types of operations in pharmacy. So these are pharmacy calculations pertaining to the number of doses, dispensing quantities, and or ingredient quantities. These calculations are performed in the pharmacy on a daily basis, So you need to have full working knowledge of this. Many of the calculations can be performed using the previous principles introduced earlier, and since we started doing math. Examples of these are ratios and proportions, okay? And cross multiplying to solve for X. That's pretty much it. Now it's important to emphasize the definition of what a dose is. So dose is the amount of medication prescribed to be taken at one time. Example, if your doctor says take 5 mLs or 1 teaspoon by mouth twice a day, your dose is 5 mLs. The frequency is twice a day. If the doctor changes that to TID or QID, your dose will still remain 5 mLs, okay? That is exactly the definition of dose. Let's review some SIG codes here. What does this mean?
Per
4
day.
times a day.
Every day.
Every day. What
Um,
about this one?
3 times a day.
Twice a day.
3 times a day. What about this one?
At the bedtime,
What about this one?
as needed,
As needed.
What about this one?
twice a day.
Twice a day.
Twice a day. Good. What about this one?
4 times a day.
What about this one?
Every 4 hours.
What about this one?
Every 4 to 8 hours.
Good. Sometimes you might see some that look like this, which is BIW, which stands for twice a week. It's not common, but you might see it, and it's not recommended because it can be misinterpreted by the technicians, okay? So now let's look at, based on this definition of dose, let's look at exactly how to calculate the total number of doses. So the total number of doses is how much you can get out of a medication based on the quantity that you have available or that has been dispensed. So calculating the total number of doses based on the amount dispensed or based on the quantity available in stock. Now, in stock means what you have in the pharmacy available. So let's look at a SIG here. I have this SIG that says Prozac solution, and it's 1 TSP POQD. Dispense number 4OZ, okay? So in order for us to calculate the number of doses here, all we're gonna do is do the following. We're gonna take the total quantity that's being dispensed. And we're gonna divide that by the dose, the single dose. In this case, the dose is 5 mLs, because once we convert this to metric, we remember we always have to use metric. It's 120 mLs and 5 mLs. So the total quantity is 120 mLs, and the dose is 5 mLs. How many doses will I get out of here? So it's 120 divided by 5. I'm going to get 24 total doses, irrespective of whether this is BID, TID, QID, okay? It doesn't matter. The frequency is not considered here when you're taking or calculating the total number of doses. Irrespective of that, you're going to get 24 doses if each dose is 5 mLs. But what if the dose or the sig changed to this? What would be the amount of doses that we can get?
15.
So 15 doses, how did you calculate that?
2 times a day, 15. We know 1 tablespoon is equal 15 milliliter twice a day.
Where does it say twice a day?
So in the morning and in the evening.
Well, what does it say twice a day anywhere on here?
BID.
Where does it say BID here? On this prescription. This is the prescription I'm looking at.
Oh, in this prescription. We don't have BID.
You don't
here.
have it, right? So even if you did have it, the frequency doesn't matter. What is the dose?
15.
120 milliliters.
So 120 is the total amount we're dispensing. The dose, the new dose, is 2 TBSP. What is 2 TBSP equivalent to?
30 milliliters.
30 mLs. Good. 30 mLs. So 120 divided by 30 is equal to only 4 doses. That's the only amount. We can only get 4 doses out of this bottle. Okay. Great. So that's pretty much what calculating doses are. Questions? Okay, let's look at another prescription here. And the prescription is for ibuprofen, 400 milligrams, and their tablets. The SIG says 1 or 2 PO, Q6 hour, PRN, pain, dispense number 120. How many total doses are in this prescription? Rhea. Okay, I'll give that one to you. Now, in medications that are controlled substances and medications that are for pain, you are going to assume automatically that the patient will take the most number of doses, the most number of times per day. So here they're given the option. So I'll make a side note here. Always use the higher dosage amount when performing I'm sorry, I got disconnected. Okay, let me see if I can lose my what I was writing. Seems like I did. Okay, let me type it out again. So we're trying to figure out, the prescription is ibuprofen, 400 milligram tablets. This is prescription strength, by the way. The SIG says I to IIPOQ, 6 hours, PRN pain, dispense number 120. How many total doses are in the prescription? So one way you can do this is the method I showed you in the before we got disconnected. Another way we can do this, by the way, anytime you get medications for pain or controlled substances, assume that the patient will always take the most number of tablets, the most number of times per day. And this is to calculate day supply, but for this purpose, we're calculating dosages. So assume that we're dispensing 120 and the patient will always take two tablets. So this is going to give us 60 doses. 60 doses. Now, another way we can calculate this is if one dose is how many tablets? One dose is 2 tablets. How many doses? What's wrong with this pen? Doses are there in 120 tablets? Those are two ways to solve these problems. So now when we cross multiply, X will still equal to 60. 60 doses, okay? Now doses and tablets in this specific problem, they're not the same, okay? Because one dose is 2 tablets, all right? So keep that in mind. Now notice that every time I try to solve for X, I'm always putting a subscript of the unit that I'm going to have the answer in at the end, so that you don't have to guess 60 doses, 60 tablets, 60 milligrams, 60 mLs, 60%, and you know exactly what it's going to be. I think I showed you this, but I want to reiterate it. Every time you set a proportion, your units must be across from each other like this, or they can be across from each other like this. One dose is equal to 2 tablets. How many doses are in 120 tablets? So notice that here we have dose and tablets and tablets. This is the correct way of setting up a proportion. The incorrect way to set up a proportion is if I say one dose, X doses, and then we have 2 tabs, 120 tabs. Notice that in this problem, tabs and tabs, tabs and doses are diagonal from each other. They cross. This would be an incorrect way of setting up a proportion. You can still get a value for X, but it would be the incorrect value. So don't make that mistake. Many students, even with experience, end up making this mistake. Okay, let's look at this one here, another prescription. I have the medication Pardura, 2 milligrams, and the SIG says IPOQD. The dispense quantity says number 90. How many total doses are here? So without even calculating or trying to use the formula, you can easily calculate the number of doses, total doses. How many total doses can you get out of this prescription? What about down here? So remember, the formula is quantity dispensed over the dose.
90.
90. 90 total doses. Okay. Here's another prescription. We have how many dropperfuls, and every dropperful is 2.5 mLs dosage are in a 50 ml bottle of airy head drops. How many total doses are here?
20.
20. So we have 50, which is the quantity of the bottle. And then that we're going to divide over the 2.5. Which is the amount of every single dose. And this will give us just 20 total doses. Questions on this? Let's look at another one here. Vicodin 500. Sorry, 500. Sig says 1. How many total doses can you get out of here?
$25, I think.
25. Good, 25. So it'll be 50 divided by 2. So 50 is the number that we're dispensing, and the dose, because this is for pain and it's also a control schedule 2, they're gonna take 2 tablets instead of 1. Okay, great. Let's go on a break. We come back at 7:30 and we'll continue.
spinning around, dancing in the dark, dancing in the dark, dancing in the dark. We're spinning around, dancing in the dark. He's on me back and nothing looped. This won't be shy. I know that you feel like me too. Don't be afraid.
I want to get attendance here really quickly. Take it later. It's okay. Okay, now let's move on to the next portion. Well, actually, let's do these two problems before we move on. How many 1 teaspoon doses are in each bottle of Zithromax, 200 milligrams per 5 mLs? If the bottle says that 30 mLs total volume after mix. Then we'll have Ina. And then the next bottle says how many doses are provided in the prescription below. The prescription below is regular insulin, U100, 100 units per ml. Sig says inject 20 units, QAM, dispense number 1 vial, 10 mLs. And I'll give this one to Rhea. Everyone should work on the problem, even if it's not assigned to you. You have an answer, Ina? You're muted.
Okay, so we know 1 teaspoon is equal 5 milliliter.
Mhm.
So 30 milliliter divided 5 milliliter is going to be 6.
So this is 5 mLs, and we have a total of 30 mLs divided by 5 mLs, which is the dose, is equal to 6 what?
6 milliliter ml.
Mm.
No, it's the same.
The number is right, but what's the unit? What's the question asking?
Doses.
How many
Doses.
doses? Yeah,
Correct.
doses.
Okay, good.
Why did I say milliliter?
I don't know. We'll let it slide this time.
Do you know the time here in Albania is, let me see, is
Oh, you're in Albania
oh,
now, right? That's right. You told me.
yeah,
That's right. Okay.
1:39
I was
a.m.
looking for the pink room. How's the weather over there?
It's
Cold?
good. It's cold. No, very, very well. It's
How long are you
cold.
staying there for?
I'm going to stay for 3 weeks. So
3 weeks. Okay. What's the time there
yeah,
now?
it's
Like 1 in the morning?
1:39. Yeah, in the morning, 1:39 a.m.
Yeah. Is it everybody, you or just you or the whole family?
All my family live here.
Okay. All right. Okay. So Rhea,
Is it 2 doses?
2 doses. Okay. Anybody have a different answer for this one?
5 doses.
5 doses.
Oh.
Any other answers? I heard somebody else say something.
10 doses.
10 doses. Any other answers?
100.
So 1 ml is equal to 100 units. How much is the vial? The vial is 10
10.
mLs. So 10 mLs. How many units is that? So cross
10.
multiply, that's 1,000 units. Okay, is equal to X. So this vial, we can say it's 1,000 units. So this is the total amount that we're dispensing. How much is the dose? 20 units. This is the dose. 1,000 divided by 20 is equal to 50. 50 doses. 50 doses. Now we could solve this using units. We can also solve it using mLs. Now in this case, we have to convert 20 units into mLs. 20 units, it's 0.2 mLs. So again, if 1 ml is equal to 100 units, 20 units is equal to how many mLs? X is equal to 0.2 mLs. Okay, if I say 30 units, how many mLs is that? If I say 20, it's 0.2. If I say 30, how many mLs?
0.3.
0.3 mLs.
Minus
If I say 5 units, how much is that?
0.5.
0.5?
0.5.
You sure?
No.
So you're saying 5 units is bigger than 20 units and 30 units?
No.
Is that gonna be 0.05?
Very
No.
good, 0.05 mLs. What if I said 80 units? 80 units,
0.008.
0.8 mLs.
Uh,
Okay. What if I said 100 units? How many mLs is that?
1.
1. Good. Okay. So these things you can calculate by yourself. So 10 mLs is the total. And the dose is 0.2 mLs. That's the dose. If you divide this, it's still going to give you 50 doses. So you can still get the same answer using the same different units of measure. Okay. So this is method 1. This is method 2. This is a basic conversion factor, so you'll have to memorize this, okay? Memorize that. 1 ml is equal to 100 units. Great. So that's calculating total dosages. The next one is calculating the quantity to dispense. How much are we going to dispense? So determining how much we're going to dispense is very important when it comes to the insurances and the auditings. So determining the proper amount or quantity to dispense is another critical dosage calculation. So let's look at a problem here. We have Biaxin, 250 milligrams. The SIG says YPOBID times 10D. How much are we going to dispense in this problem? So based on the SIG, the formula is the following. In order to find out day supply quantity to dispense, we're going to take the dose times the frequency times the duration. So in this case, my dose is what? My dose is 1 tablet times the
Twice a day.
frequency twice a day times
For
the
10 days.
duration 10 days.
20.
So I'm going to dispense a total of 20 tablets. 20 tablets. Easy enough. Okay, promethazine. Are you both from the same city or different cities, Rhea and or no?
I don't know which city she's from.
What city you're from, Ina?
I am from Corta.
Corta?
Oh yeah, we're from the same. We have the same hometown. Yes.
Yeah, maybe same the neighborhood. When I was going to middle school here in New York, one of my classmates ended up living in the block or 2 blocks behind in the house where I used to live back home. And we ended up meeting here like years later. This is promethazine codeine syrup. And this says 6.25/10. Again, this means that the strength of the promethazine is 6.25 milligrams, and the strength of the codeine is 10 milligrams. The SIG says 1 TSP POQID times 4D. How much are we dispensing? Mia. So what's the first thing we need to do when I look at this problem? Hint, look at measurement systems.
You have to find the number is blank, right? Is that
Well,
is
we're
that
finding the quantity, but when I look at the SIG, for example, what do I see there that as far as metric systems?
teaspoons?
Okay, what do we need to do with that?
Convert.
Yep, convert to
5.
metric. So this is household, we need to convert to metric. What would be metric? MLs. So 1 teaspoon is how many mLs?
5.
5 mLs. Okay, so based on this formula up here, the dose is 5 mLs times the frequency, which is, what does QID stand for?
Four times a day.
4 times a day, and then the duration is
4 days.
4.
4 days. So 5 times 4 is 20.
20
and
times
20
4.
times 4 is 80.
This is
80 what? mLs.
Milliliter.
Because this is a syrup. Syrup. Okay, let's look at this simple one, Anna. Zoloft 100 milligrams, IPOQD, dispense 1 M supply, 1 month supply. How much are you dispensing?
30.
30. Number 30. It's just 1 tablet daily. That's it. 30 is the duration, assuming that when it says 1 month supply, you always assume 30. People ask me, what if it's 28? What if it's 29? What if it's 31? Just 30. Stick to 30. Okay, here's another one. Pamela. So we have what quantity should be dispensed using the stock medication to provide 20 milligrams of diazepam prior to the procedure and 10 milligrams following the procedure. Okay, so the bottle says in stock, we have the medication called, this is what we have on the shelf. It's diazepam, oral solution, 5 milligrams per 5 mLs. This is a controlled substance scheduled 4. And it gives out other information, very tiny, it's not relevant. But what we need here is the 5 milligrams per 5. So Pamela, how much am I dispensing on this prescription?
Okay. How much we're dispensing? We're dispensing 30 milliliters.
Very good. That's it. 30 milliliters.
Well,
that's
it
all
says
we're
milligrams.
dispensing.
It says mg.
Yeah, but remember, this is a solution.
Okay. Oh, yeah. Okay.
So 5 milligrams is equal to 5 mLs. 20 milligrams is equal to 20 mLs. 10 milligrams is equal to 10 mLs.
Yes.
Great. 30 mLs.
30. Mhm.
People say, well, how does this fit into the formula you gave us? Well, what is the dose? It's 1 dose prior to the procedure. So that's 20 mLs, 1 time prior to the procedure, and it's just for 1 day. So that's 20 times 1 times 1. And then following the procedure, 10 times 1 times 1. Here's another one, Christina. So we have furosemide, 20 milligrams, IPOQOD, dispense 3-month supply. And I'll put one here for Rhea. What quantity should be dispensed when 50 milligrams of amitriptyline has been prescribed daily for 3 weeks? In stock, there is 25 milligram tablets. And then here we have this one for Anna. Soma, 350 milligrams, IPOBID, TID, PRN, muscle spasms. What's the quantity to dispense for a 30-day supply? I'm going to change yours, Anna, to this. Okay, the SIG. I just changed the SIG, Anna.
So mine
Mhm.
should be 180 tablets.
Anna says hers should be 180 tablets. Okay, so how did you get that answer?
Because it says that the person needs to take 2 tablets, well, 1 to 2, but we're gonna take the maximum amount, which would be 2 to 3 times a day. So we're gonna take the 3 times a day.
Mm-hmm.
And so that would make it 6 pills a day.
Mm-hmm.
Then 6 pills times 30, that's 180.
Good. How about Rhea?
Is it 42?
42. How did you get that?
So supposedly we are taking 2 tablets per day.
So times 2, that gives me 50 milligrams. And
And
it's
3 weeks is.
And that's daily, so that's 1. So that's 2 times 1 for 3 weeks, which is
21.
21 days is equal to 42 tablets. Good. Christina, what's your answer?
I don't know.
Okay.
I'm so sorry. I didn't get it yet.
Who has this answer?
90.
What do you have?
1 tablet by mouth every day.
Mm-hmm.
So for 3 months, 3
19.
multiply 30 equal 90.
90.
I
Okay,
have 45.
he has 45. Any other answers? Who else says 90? Who else says 45? Why do you say 90? I'm sorry, 45, Anna?
Because it's every other day, right?
UOD is every other day. So you're skipping a day. So if you skip a day in a month, you're only taking it 15 times in the month. Times 3, it's 45. You see that now? So yes, the quantity is 45.
45.
Great.
Other thing.
All right, let's look at now calculating the quantity of ingredient. And this is the ingredient in the product, the active ingredient. So it is sometimes necessary to calculate the amount or quantity of active ingredient. So the active ingredients, what actually will work on the patient, required, particularly when preparing compounded preparations. So let's look at the problem here. How much codeine is in each dose of codeine phosphate oral solution, 15 milligrams per 5 mLs? Okay. The SIG says, or the bottle says, bottle in stock states that codeine phosphate oral solution has a strength of 15 milligrams per 5 mLs. The bottle size is 500 mLs, and this is a C2 substance. The SIG says 1 TBSP, POPRN pain, and we're dispensing 4 ounces. Okay. So if we have 1 tablespoon, that means that's 15 mLs. We want to figure this much is how much is this in milligrams? Well, we know that 15 milligrams is equal to 5 mLs, And we know that we're giving 15 mLs. How many milligrams is that? Cross multiply 5x is equal to 15 times 15 is what? 225 over 5. This cancels out. NX is equal to 45 milligrams. So 1 tablespoon, which is equivalent to 15 milligrams, 15 mLs is equivalent to 45 milligrams. So you're dispensing 15 mLs, which is equivalent to 45 milligrams of the active ingredient. Let's look at another one here. How many mLs of stock dopamine must be added to the IV solution? So we're going to make our first IV. The doctor's order says dopamine 400 milligrams added to 500 mLs of NS. Remember, NS means normal saline, which has a percent strength of 0.9%. The SIG, or actually the stock amount, says that the dopamine HCl injection has a strength of 80 milligrams per ml. So we need to prepare this IV. How do we prepare it? Well, if what I have in stock means I have in the pharmacy is 80 milligrams per ml, and I need to give 400 milligrams, how many mLs is that? Cross multiply 80x is equal to 400, divide both sides by 80. This cancels out, and x is equal to 5 mLs. So this equals to 5 mLs. So in the pharmacy, we have a vial, which is the dopamine, 80 milligrams per ml. Maybe this is a 30 ml vial. Sometimes we have multi-dose vials. So we're going to take our syringe and draw 5 mLs of the dopamine. Here we have the IV bag. Here are the ports. And then this amount, and this is the normal saline, 0.9%. And this is a 500 ml bag. So in this ports, we're going to take, after we draw this, we're going to take and insert in here this amount. So now we have this amount, which is 5 mLs, into the bag. And this 5 mLs gives a strength of 400 milligrams of the dopamine. That is the preparation of an IV. Questions? Okay, let's work on some other problems related to this. So let's say on number 1, Z-Pak contains 6 tablets of azithromycin, 250 milligrams, which are taken over the course of 5 days. How many total milligrams of active ingredient are contained in a Z-Pak? We'll have Rhea. Number 2 says, how many micrograms of fentanyl would be contained in a 1.5 ml? Stock fentanyl is 100 micrograms per 2 mLs. And we'll give this one to Ina. Next one is how many milligrams of acetaminophen are contained in 2 Lortab 2.5 milligram tablets, 2.5 milligram hydrocodone / 500 milligrams acetaminophen. Pamela. How many milligrams of dexamethasone are contained in the stock bottle, 500 mLs. So the bottle says dexamethasone, oral solution, 0.5 milligrams per 5 mLs. Total volume is 500. And then we'll give this one to Ria, Ina, Pamela, Anna. And then lastly, how many milligrams of hydrocortisone are found in 1 teaspoon of Fortef, 10 milligrams per 5 mLs. And this one is Christina. Oh, Mia. I haven't picked on Mia. So we'll change this one to Mia. I'm missing somebody.
Yeah.
And whenever you have your answer, just unmute yourself and let me know you have it.
So Ina,
Okay.
so we know we have 100 microgram in 2 milliliter, but what about 1.5 milliliter X? So the X is gonna be 75 microgram.
75 micrograms. Great. Great. Perfect. Everybody
I
asleep?
think mine, Pamela.
Yeah, Pamela.
Is it 1,000 milligrams?
Okay, so yours is asking about how many milligrams of acetaminophen are contained in 2 tablets of 2.5 milligrams Lortab, which has a combination of hydrocodone and acetaminophen. The strength of the acetaminophen is 500 milligrams, but if you're taking 2 of those, you're saying it's 1,000 milligrams. Good.
Okay.
1,000 milligrams. So if 1 tab is equal to 500 milligrams of APAP, then 2 tabs is equal to X milligrams of APAP. And you can cross multiply this, and that gives you 1,000 milligrams. Good.
I have mine 1,500 milligrams.
1,500 milligrams. So the Z-Pack contains 6 tablets. So 6 times 250 is equal to 1,500, right? Okay. How about Ina? Who did that one? About Anna?
That would be 50.
15, 15, 50, 50. 50 what?
50 milligrams.
50 milligrams. And how did you solve this?
Because you have in 5 milliliters you have 0.5 milligrams. So then in 500 milliliters, then you know how much. So
Yeah,
then if
so
you
you cross
multiply
multiply.
500 times 0.5 divided by 5, then you get 50.
Good. And whenever you're ready, Mia.
Is it 5 milligrams?
5 milligrams. And how did you solve that?
So I put the 10 over 5 and then
Yes.
I cross multiplied it by 1 over x.
So here's what happened. What unit of measure is this? You
Oh,
had the right process, but the wrong units.
oh, okay.
So this is what in the metric?
5.
5 mLs. So 1 teaspoon is 5 mLs. So 5 mLs goes down here and the X
okay.
up there.
Yeah.
So when you cross multiply, so that's 5x is equal to 50. Divide both sides by 5. This cancels out. And X is equal to 10
10
milligrams. 10 milligrams. Okay. So be careful with those, okay? Be careful with the units of measure. We always work in math for pharmacy, medicine, in metric. We don't use teaspoons, we don't use tablespoons, we don't use ounces, cups, or gallons. If it does present, the problem does present those units, immediately convert to metric, Okay. Calculating the correct day supply. This is also very important when it comes to auditing. Calculating the correct days supply. So the expected duration for a prescription being dispensed. How long the amount of medication dispensed will last if taken as directed. So how many days should the prescription last? For this, we have a formula. So the prescription is this: Pamelor, 75 milligrams. The SIG says 1 PO BID, and the quantity is 50. So these are capsules, Pamelor. Great. Formula for this: to calculate days supply is the following. So we're going to take the quantity dispensed, day supply, quantity dispensed, and this is going to be divided by my dose times the frequency. Dose times the frequency. So in this case, this is equal to quantity dispensed 50 over my dose is 1 times my frequency 2. So 50 divided by 2.
25.
25. 25 days. So this will last 25 days to the patient. Here's another example. Medication is an HIV medication. 133.3, 33.3 milligrams, 1 or 2 POBID with food. And then dispense number 360. Okay, I'll leave it there and then we'll go on our break. Okay, I'll see you back here at 8:30. 8:30. Let's continue here. Medication diabinase, 100 milligrams, IPO QAM, dispense number 45. What is the day supply here? Here's another one. I have this one to Pamela. I have one here. How many days? Only 150 ml bottle of C-chlor, 125 milligrams per 5 mLs. Last, if the patient is to take 2 TSP PO TID. I'll give this one to Mia. And then how many days will the RX last? Christina. The RX is Valium, 5 milligrams, IPO BID, number 60.
For me, I will say 60 days, one per day.
60
60
days.
days, 2 months. Yeah.
So this one here. So how many is it per day?
One.
What does BID mean?
A bit, twice. That's 30.
So
30
this will
days.
last 30 days.
30
Great.
days, twice a day.
All right, great.
It, Pamela, it's in mine 45.
Day supply for yours is 45 days, correct. And I gave Mia this one just on purpose. Let's see if we caught on with the measurement systems.
So for the quality dispensed, would it be 5 milliliters or 125 milligrams?
So we're trying to calculate the amount of days that this will last.
Right.
So you said how many days?
Um,
The
no,
quantity
I said,
dispensed, you said 150, right?
I said 125, but I was kind of confused. Is it 150?
Okay, it is 150. So the quantity
Okay.
dispensed is 150. 125 is the strength. What is the dose here?
Oh, 2 teaspoons. So would that be 0.2?
So
Like
2
for-
teaspoons in mLs, how much is that? 1
Um,
teaspoon is 5, 2 teaspoons is?
10,
10.
Great. And TID means
3 times a day.
3 times a day. Great. So. And then, so now the dose, we said it was 10. And then the frequency was 3. So that will be 150 divided by 30, which is equal to, if we take this off, 15 divided by 3 is just 5 days. So this will last the patient 5 days. And C-chlor is an antibiotic, so usually antibiotics won't really last that long. So the key here is to remember to convert to metric. You got to remember those metric conversions. I just want to reiterate, 1 teaspoon is 5 mLs, 1 tablespoon is 15 mLs, 1 ounce is equal to 30 mLs, 1 cup is equal to 240 mLs, 1 pint is equal to 480 mLs, 1 quart is equal to 960 mLs, 1 gallon, 3,840 mLs. 1 pound is equal to 454 grams, or in the liquid version, it's 16 ounces. And then 1 kilogram is equal to 2.2 pounds. So these are things you need to remember for the pharmacy calculations. All right, let's finish this set of problems of dosage calculations with a multiple dosage calculation. So the medication we have in stock, or the prescription we were given, is 250 milligrams per 5 mLs. The SIG says 1 TSP TID times 10D. So the first question associated with this SIG is the following. A, what is the appropriate quantity to dispense? So we'll give this one to Ina. Second question is, how many total doses are to be dispensed? Ria. What is the total amount in milligrams to be dispensed? Anna. Using. And then how many days should this prescription last? We'll give this one to Pamela. And then on the side, I'm going to give another prescription here. So the RX is for Proventil inhaler. $17 grams, 200 inhalations. Sig says use. PO plus PID. Dispense number 1. What is the appropriate quantity to dispense? Christina. How many total doses are to be dispensed? Mia. What is the total amount of albuterol in milligrams per inhalation? Ina and Lee, how many days should this RX last? Rhea. Just let me know when you have your answer.
So let's start with the first one. Ina.
Okay, Ina.
So the first one is 150.
150 what?
What is
What's the unit?
milligram?
Milligrams? Sure. What form of does the medication come in?
Milliliter.
Milliliters. It's a liquid. So teaspoons,
Yeah,
right?
because
Okay.
it's teaspoon.
Correct. What about on the other one? You have the other one, the second one?
I think it's 2.
2? This one here, Rhea, 2?
Yes.
2 doses total? What about the rest? What do you all think? Did everybody get 2 doses?
I got 30 doses.
30 doses on this one.
Mhm.
Who say 2 doses? Who says 30 doses?
Very doses.
30 doses? Okay, good. So the first one here is, what is the appropriate quantity to dispense? So the first thing we do is convert the teaspoons into ml. That's 5 mLs times 3 times 10. Quantity to dispense is dose times frequency times duration. 5 times 3, 15. 15 times 10 is 150 mLs. Then, since we are dispensing 150 mLs, my dose is 5 mLs. That's going to give me 30 doses, which is what we got here, 30 doses. What is the total amount in milligrams to dispense? So that's Anna. What do you have?
That'll be the same, 150 milligrams.
150 milligrams. Okay, tell me how you got that.
Because it's milliliters is the same as milligrams.
No, they're not.
Yeah, 1 milliliter equals 1 milligram. So if
No,
you got
not in this
150
medication. In this medication, 250 milligrams is equal to 5 mLs. You can't use that as a general rule.
Well, what I do is you have 5 milligrams 3 times a day.
Where do you have 5 milligrams from? 5 mLs.
5 milliliters 3 times a day, that's 15 milliliters a day. Times 10, that's 150.
Yeah, but we're doing this one here. You're saying that 150 mLs is equal to 150 milligrams?
Yeah.
No. No. That's not correct. In this medication, amoxil, 5 mLs is equal to 250 milligrams.
It's gonna be 7,500.
7,500. So if we have 250 milligrams equal to 5 mLs, we want to know how many milligrams is there in, we know that the total volume we're dispensing is 150 mLs. So now we cross multiply 5x. Is equal to one, how much is it?
7,500.
7,500. 250 times 7, what's 150? Is 37,500. 37,500. And then we divide by 5. And that equals to 7,500. 7,500 milligrams. Okay. So in order for you to have calculated this, you needed to have known the total volume. We already know the strength of the medication. You can't always make that assumption that 1 milligram is 1 ml. That's specific per medication. So in this specific medication, 250 milligrams equals 5 mLs, or vice versa. 5 mLs is equal to 250 milligrams. And how long will this last, Pamela? This is a trick question. Super easy.
Wait. Now I'm rethinking it.
The answer is in the question.
I think it was gonna be 10 days.
Good. It says right there, 10 days. Is this clear, Anna? Or are you still confused about this?
Yeah, no, it is just I didn't understand the question.
Oh, okay.
That's what it was, yeah.
You weren't looking for this? You weren't looking at this? Is that what it was?
Yeah, I wasn't looking at that. I didn't understand the wording of the
process.
question.
Okay, that's fine. Okay, now on this one, Christina, what is the appropriate quantity to dispense? Another trick question. How much should we have dispensed? The answer is in the question for you.
1.
1, exactly. We're dispensing 1. That's what the doctor said. How many doses are to be dispensed? Mia. Didn't somebody say in this class they were asthmatic? Or no? No. Okay. So 1 inhaler is able to provide 200 inhalations. Okay. 1 inhaler gives 200 inhalations. So that is the total amount we're dispensed. That's the total. What is 1 dose? 1 dose gives us the option of either 1 puff or 2 puffs. However, realistically, an inhaler doesn't provide 2 puffs at a time. It just still provides 1 puff. But I just do it consecutively. 1, and then the other one, 2. Right? But it's still 2 different. I'm pressing twice to provide the 2 dose, the second dose. So this is a trick question. How many doses are to be dispensed? It's 200. 200 doses. I am able to get 200 inhalations or 200 doses. Even though it says 2 puffs. Every puff is just an individual. Even if it says 3 puffs, I have to do 1, 2, 3. I don't just press and say, oh, that's 3, unless the medication does that eventually at some point, but none of those that I know of so far do this. So this is 200 doses. What is the amount of albuterol in milligrams per inhalation?
So we have to convert gram in milligram.
Okay, so she says grams to milligrams. How much is that?
So it's gonna be, we're gonna put 30 to the.
So that's gonna be 17,000 milligrams, right?
Yeah.
Okay. Then what? Are you done?
No.
What else do you need to do? The question is asking per inhalation, not in total, but per inhalation.
So we have to divide it
by
200.
Divide this by 200. How much is that?
So 200 is gonna be 85
milligrams. 85 milligrams. Okay. So the inhaler has a total of 17 grams. and it provides a total of 200 inhalations. So I have to divide the 17 by 200 inhalations, and that'll give me the amount of inhalations in grams. But the question is asking me to provide the answer in milligrams. So I have to convert the grams then to milligrams. She did that first, grams to milligrams, and then divide it. Either way is fine. And how many days will this last, Rhea?
50 if they use 2 puffs, 100 if they use 1.
50 days, right? So 2 puffs twice a day. We always assume that they're going to use the most number of puffs per day. So we're going to assume this one, the 2 twice a day. So that's 2 times 2 is equal to 4. And 200 divided by 4 is 50 days. 50 days. Okay. Questions on this? Okay, now as part of dosage calculations, though many of these calculations aren't really performed by technicians, they're more for like nurses, we still have to learn them for the national certification exam, and they're called pediatric dosages. There's 3 types of rules that allow us to calculate pediatric dosages. The first rule is called Fried's rule. And Fried's rule says that we can calculate the child dose by taking the age in months, okay, over over 150. 150 is considered the ideal adult weight. And this we're going to multiply times the adult dose, which I will use later on as AD. That will give us the child dose. Now, another formula or another rule that we have is Young's rule. And Young's rule says that we can calculate the child's dose is calculated by taking the age in years of child, and we're dividing this over the age in years plus 12. Plus 12. Times the adult dose, times the adult dose. The third rule that we have, it's called Clark's rule. And Clark's rule says that we can calculate the child dose by taking the age, the weight in pounds divide this over 150 and multiply this times the adult dose. So one way I tell students to remember Young's rule, for example, is the Y in young and Y in years. Young's rule, years. Fried's rule and Clark's rule are both divided by 150. Freed, divide the age in months. Clark's weight in pounds. Now, it is said that Freed's rule is supposed to be used for patients from 0 to 2 years of age. Young's rule from 3 to 4 to 12. And then Clark's rule from 14 to 17. Why only until 17? Why do you think only until 17?
Because 17 and over, we consider like adult.
At 18, you're considered an adult, so they get the adult dose, correct? Okay, for the next problem, we're gonna use the same example and try to solve the dosage, the pediatric dosage for this patient using the same problem and different rules, okay? So an infant, 15 months old and weighing 20 pounds, needs the medication streptomycin, sulfate, which is usually administered to adults as 1 gram, which is equal to 1,000 milligrams in a daily IM injection. What is the appropriate dosage for the infant? Okay, so here we have the problem, and we're going to use this problem for all 3 rules. So let's solve using Freed's rule. And by the way, some students ask me, well, how do I know which rule to use when the problem is given to me on the test? The test question will give you, and will tell you which rule to use. So you don't have to guess based on the information that's provided. It'll say using Young's rule, using Freed's rule, using Clark's rule, calculate the pediatric dosage. Okay, so in this case, we have Freed's rule. Child dose is equal to the age in months, which is 15 months, divided by 150, and the adult dose is 1,000 milligrams. So we have 15,000 divided by 150, get rid of a 0, that equals 100 milligrams per dose. That's the child dose, 100 milligrams per dose. That's using Freed's rule. Now using Clark's rule, I'm sorry, using Young's rule, it says that the child dose is equal to age in years. Well, age in years, 15 months in years. So 1 year is equal to 12 months. 15 months would be plus 3 months. So 3 out of 12 is equal to 1/4. So 15 months is equal to 1 year and 1/4 years. So 1.25 over 1.25 plus 12 times the adult dose, which is still 1,000. So 1,250 divided by 13.25. This equals to 1250 divided by 13.25, 94.33. So we're going to say about 94 milligrams. The child dose will be about 94 milligrams per dose. And then finally, using Clark's rule, the child dose is calculated by the patient's weight in pounds, which is 20 pounds, divided by the 150 adult ideal adult weight times the 1,000 milligrams. This gives me 20,000 milligrams divided by 150. Child dose is equal to 20,000 divided by 150, 133, about 133 milligrams per dose. So you can see that using these three rules, you get different dosages for the patients. So again, if you get problems like this on a practice test on certification exams, you will be told which rule to use. You don't have to guess and find out. Number one. Number two, you will be provided the information necessary to apply that rule. In practice, US technicians don't have to calculate these dosages, to be honest. That's mainly done either by the doctor or the nurse, perhaps the pharmacist. But that's typically what you do with these. Again, why do I show these? It's because you'll probably have questions on them on the national certification exam. When I took my exam, I had questions, I think maybe one question, and it was, I think, applying Young's rule. Otherwise, I never saw it in practice ever again.
I have a question about this.
Mhm.
So shouldn't all the answers be the same
No.
based on no?
Because you're
'Cause-
using different,
Yes.
you're different numbers.
Yeah, but I'm saying like in base of medication, like it's the same child with the same weight and stuff.
know.
Like with it's different medications?
No, it's the same medication.
Yeah.
You wouldn't be able to get the same answers for all of them because the formula is different. Each rule is different. Each rule requires different numbers. So you wouldn't be able to get the same medication. Now, it's a good question you asked because I just want to emphasize reasons why these rules aren't used much anymore. It's because of this. You don't really get a proper answer or an accurate dose that would be suitable for a patient. At times we have patients who are 13 years old and they look like 17-year-old kids, or adults that have genetic conditions that are born like dwarfism, and they have the body size of a child. Okay, so in those cases, we cannot provide an adult dose on that individual just because of their age, because they're over 18 and they're an adult. We have to calculate a dosage based on body surface area, which is another pediatric dosage calculation I'll show you, which is a more accurate type of calculation, one, because it allows us to calculate a dosage based on body surface area. We have kids that are tall, that are very big in mass. We have others that are shorter in mass, less, let's say, developed. We also have to consider other things such as conditions that the individuals might have. So those that are much more developed probably have more developed organs as well. But you can see that the dosages within one another aren't really much of a difference. Perhaps somebody can take the average of these three calculations and say, let's give them something within this range.
Okay, that's what I was gonna ask. So which one should be like the right one to go?
Well, in this specific patient, we have the infant, which is 15 months old. So most likely we'll use the freeze rule.
Okay.
Yeah.
All right.
We wouldn't use Young's rule because again, it's 15 months old, though we can convert 15 to months, but again, this is more considered for 0 to 2 years of age.
Okay.
And we wouldn't use Clark's rule, which is mainly used for teenagers to near adult stage. Okay, so those are the three rules. I want to show you the other calculations, which is calculating the dosage using milligrams per kilograms per day. That's another way to calculate. So first thing we need to know is that 1 kilogram is equivalent to 2.2 pounds. I already discussed that. So it's important for us to know how to calculate. So if we want to calculate pounds to kilograms, we want to divide by 2.2. if we want to calculate kilograms to pounds, we want to multiply by 2.2. Multiply by 2.2. So let's look at that same problem from that child. Based on that child, this formula is also used for adults in certain medications. So determine the pediatric dosage if it is recommended that 20 milligrams per kilograms per day, maximum of 1 gram of streptomycin sulfate. Determine the pediatric dosage recommended 20 be used when the patient weighs 20 pounds. So what would be the first thing for us to do? To convert the 20 pounds to kilograms. So again, 20 divided by 2.2 gives us 9.09 kilograms. Okay, so now we got that. Now we know that this is equal to that. Since for every kilogram, we're going to give 20 milligrams, we're going to multiply this times 20 milligrams. And that's going to give us 181.8 milligrams per day, 181 milligrams per day. Now, lastly, the other way to calculate pediatrics dosages is calculating pediatric dosages using the BSA, body surface area, which is a much more accurate type of manner. Now, we don't have to know how to calculate the BSA. That's usually and typically something that's already provided to us. What we have to know is this formula. Or first of all, what we need to memorize is the following. Average adult BSA is 1.73 centimeters squared. Centimeters squared. Remember, we started doing measurement systems, and this is the only time in where we'll be using. I'm sorry, it's not centimeter. I can't believe I did that. Okay, let's see. Okay. Meters squared. Oh. Supposed to be meters squared. Meters squared, okay? Or squared meters. So you need to memorize this. Memorize this conversion. BSA or child dose using the BSA formula is the following. Child BSA in meters squared times the adult dose is divided by the average adult BSA in meters squared. So this is provided in milligrams. So this cancels out, this cancels out. And then if, for example, we have a child BSA, which is 0.83 meters squared, and an adult dose, which is about 100 milligrams, we divide this over 1.73 meters square. Again, this cancels out, this cancels out. This gives me 830 over 1.73. The child dose using the BSA is 830 divided by 1.73. 0.83. Sorry, this is 83, not 830, 83. And then divided by 1.73 gives me 47.9, about 48 milligrams per dose. So it's almost half of the adult dose. Almost half of the adult dose. So these are the formulas. And we're done with dosage calculation. So next class, we'll start off with concentrations and dilutions. I'm going to send a homework over through Google. So be on the lookout for that. So next class we'll start, and the homework will start off with pediatric dosages. It'll just be that. The rules, milligrams per kilograms, and that's about it. The BSA, not so much. In a problem, I want you to keep in mind that if you get a pediatric dosage problem, you will be provided this and this, both provided in a problem. You must memorize this and know that and plug it into the formula. Now, I sent you all an email through Google Classroom that next week, Thursday, we will have our midterm. So check Google Classroom so you can see the topics that will be discussed in there.
Did you say next Thursday? Like
Next Thursday, yes.
What
Yes.
is
So
that? Meeting?
Midterm. So an exam midway through the class.
Exam. Okay.
Yeah. I sent that maybe a week and a half or 2 weeks ago through Google Classroom. So make sure you've read that. I'll go visit Google Classroom so you can see the review topics in there.
just so I know, it's on May 25th, right?
Yes.
Okay.
Which is Thursday, next Thursday. Yeah. That Shavat begins, right? That's a holiday, Jewish holiday. So I don't know if anybody practices, but if you do, let me know.
I don't celebrate the holiday, but that's I'm graduating, so that's the same day as that.
Okay.
That's the day of commencement.
What time is your graduation?
It's early in the morning, but then I'm gonna like go out with my family after, but I'll be back in time for the class.
Okay. If anything works out, anything you have an issue with timing, let me know.
Okay. Thank you.
And we'll work something out. Yeah, because I have a class on Friday. So if you are not able to attend, you can join me in a different, I don't have a class on Friday. You can join me. That's fine. You can join it on Friday and then you'll be the only one there. If you can't do it that Thursday.
Okay.
Yeah.
Okay.
Yep. So be on the lookout for that email with the information, and that's it. Everybody have a good night, good weekend. I'll stick around if you have questions. Hopefully you're practicing the test and evolve, and you're all accessing the NHA material. Yes.
I'll see you next week.
Yes. Bye-bye.
Bye. Congratulations.
Good night.
Neil.
Yes, congratulations. I forgot to say that.
You left. And Professor, are you going to post this recording again?
Yes.
Okay, so we can
As soon
practice.
as I get it, sometimes it takes a couple of hours for me to get it.
All right. Thank you very much. Have a good
Okay.
night.
Good night.
Have a good night. Bye.
Good night.
Good night.
Good night.
Bye.
Night.
Bye.